Hi everyone, this is the last concept you will be learning in Math 81, and I hope you're as excited as I am about it. It is a fairly simple concept, but I want to go over how to think about it. So remember from way back, there's this idea of a like term. And like terms are things that look the same. So if we were to go back to the idea of you don't add apples and bananas together, you could say that 2 apples plus 5 apples, when you add those together, you get 7 apples. So if I said that I had 2x's plus 5x's, that would add to 7x's because we can add like terms. Now, if I had 3 apples plus 5 bananas plus 2 apples plus 7 bananas, B-A-N-A N-A-S, there we go. Then I would not go through and add them all up. I would add the bananas with the bananas, and I would add the apples with the apples. So then I would just look at how many of each I have. I have 3 apples plus 2 apples. That gives me 5 apples plus 12 bananas. Now this may seem really obvious, but let's now extend this to algebraic representations. If I have 2x squared plus 5x plus, let's make this actually just in line with what we have up here. If we have 3x squared plus 5x plus 2x squared plus 7x, we would only combine the terms that look the same. So the x squareds would be combined with the x squareds, and the x's would combine with the other x terms. And notice that I'm adding and subtracting in between these plus or minus signs. So all I do is look at the leading coefficient. That's what they call these numbers in front of the x's. And I determine what I need to add together. 3x squared plus 2x squared is 5x squared. And 5x plus 7x is 12x. Now there are some basic ideas you want to keep in mind for combining algebraic expressions or combining like terms. The first is you look at a statement, and if there are no parentheses, you just combine the like terms like we just did. But what if we were given something a little more complicated? Let's say we were given an expression like this, and I'm going to scroll up just a little. The first thing we would do is combine any like terms inside parentheses. You'll regularly see something like the word simplify and then the expression. So first we're going to simplify inside parentheses if we can. And when we do that, we'll have 2x plus 3x times the quantity 4 plus x. Next, we'll distribute anything so that we can get rid of the parentheses. So we call this using the distributive property. To eliminate parentheses. So when we do that, we'll multiply this 3x to the 4, and we'll have 12x. And then we'll multiply this 3x to the x. And remember, when we have two x's multiplied together, we get x squared, because we had an x times an x. And if you think about it, there's also a 1 in front of the x, but we don't really worry about that too much. And then we write everything else just the way it was. So at this point, we have simplified inside parentheses. We've used the distributive property to eliminate parentheses, and now we need to combine like terms. When you combine like terms, you look for the terms in between plus and minus signs that look the same. So the x with the x, and the 3x squared doesn't have any like terms. So that means that we have 14x plus 3x squared. Now you might be thinking, I'm done. I don't have anything else to do. But there is one more step that's fairly important moving forward in other classes, and that is to write in descending order of exponents. So we would write it as 3x squared, because the exponent on the 3x squared is higher than on the 14x. The understood but not visible exponent on the 14x is a 1. And we're done. So this is the basic idea of simplifying an expression or combining like terms.